while you're bringing those up here, let's take a look at, yesterday we finished everything we needed for you to do 4.3. We actually did a problem similar to what you'll see in 4.4. These are the problems I asked you to take a look at. How many of you actually did that? Not bad. That's a little more than half. Very difficult?
Yes.
Okay, a little time consuming, a little on the tedious side. Lots of little things to keep track of, but no one step is that difficult. The whole proper, improper thing, not very hard, right? Finding vertical asymptotes and holes. If that's all you're asked to do, it's not too bad. Okay, I do want to back up and let's take a quick look here, and then Alex is going to point out a mistake I made yesterday.
Yes.
Okay, hang on, we'll get there. So these two sections are about graphing rational functions. These are the wildest functions that you've graphed so far. Okay, for the most part, they're the wildest graphs that we do, period. Trig functions are a little weird, but that's okay. So rational functions are, the root word there is ratio. So we've got a polynomial over a polynomial. Okay? And it's a rational function as long as this isn't the zero polynomial. So we did some really easy ones that we're already familiar with. We did 1 over x, we did the reciprocal function, and we did the reciprocal square function. Graphed those. Notice that they both had vertical and horizontal asymptotes. Talked about domain and range and all that sort of stuff. And then we talked about proper and improper. So we were just looking at degrees. The degree here is 1, the degree here is 2, so that's proper. The degree here is 2, the degree here is 2, so that's improper, but it's the good type of improper. We'll get to that in just a second. And this is improper because the degree of the top is higher than the degree of the bottom. Okay? And the nice part about knowing whether it's proper or improper is, if it's proper, we know it's got a horizontal asymptote of y equals 0. It's that simple. If it's proper, you know the horizontal asymptote is y equals 0. If it's the good type of improper, so if they're exactly the same on the top and bottom, then it's just the leading coefficient over the leading coefficient. Okay? It's still going to be a horizontal line. If it's the bad type of improper like this is, you've got to do long division in order to figure out what the asymptote is. And it's not a horizontal asymptote. What were the words for it? Oblique or slanted, either one. Okay, so if you want to call it an oblique asymptote, that's okay. If you want to call it a slanted asymptote, that's fine too. Slanted to most people would make more sense because it's not a new vocabulary word. This one right here was the oblique asymptote. All right. Let's see. We then talked about vertical asymptotes and holes. So can somebody tell me why x equals -4 on this one is a hole while x equals 2 is a vertical asymptote? Charles. Okay, because the x plus 4 cancels out. That's a problem area in the domain. -4 is not in the domain. We know we've got an issue there. Because it cancels when we simplify, it becomes a hole rather than stays a vertical asymptote. Okay? So if those problems in the domain cancel, they're holes. If they stick around, they're vertical asymptotes. Okay, then we talked about finding x-intercepts, y-intercepts, and all that sort of stuff. And then we looked at this graph right here and figured out the domain, the range, all that sort of thing. This is a very typical type of rational function. Okay? All right. Then we looked at this ugly mess right here. It's basically putting all of those pieces of information together. It's not like you have to memorize this list step by step by step. Okay? You do enough of these, you'll have it memorized, so you'll have the process memorized. And then we graphed this one right here. So this was the first one that we had taken a look at. That was proper. So we had a horizontal asymptote of y equals 0. We had two domain issues, one right here of +1 and one right here of -1. We canceled this off. This is the simplified version. So that means at 1 there's a hole and at -1 there's a vertical asymptote. So you'll remember we sketched those on here. We did a little dotted line to show where the hole was, or just to remind us that there's a problem on the function at that place. And then we were finding intercepts. And I found the Y-intercept. You want to pick up right here, Alex?
Y-intercept is not equal.
It's not 1/2. Okay? How do you find the Y-intercept? You plug in a 0 for the x. So if we look at this simplified version and we plug in a 0 for x, We have a 1 on the top, and what do we have on the bottom? We have a 1, okay? So a little arithmetic mistake there. So that crosses at 1. Here's how easy that is to fix. We'll just make that really fat, and we'll call that point 0, 1, okay? All right. Everything else there was correct. We had the correct horizontal asymptote because it was proper. We had the correct vertical asymptote because that was a problem that stuck around. The number that you can't plug in here is -1. We've got this hole at 1. And then here's where I want you to tune back in if this is just all review and say, hey, I got this figured out. This point right here really helps figuring out what this branch looks like. The different pieces of a rational function are called branches. So this piece right here has to be up here because we talked about, well, look, if it goes through here and when it gets close to the vertical asymptote, it's either got to go up or go down. I think it was Emily that told us why it had to go up. Why can it not go down? Because if it were to go down, it would cross through the x-axis. That would produce an x-intercept, and we know it doesn't have any. There are no x-intercepts on this graph. So that means it's got to go up. Okay? It can run along here. Remember, got to have that little hole right there. And then it can't dip down below there because that would make an x-intercept. Okay, now this side over here is actually, when they're proper, it's actually a little bit of a pain in the butt because you've actually got to pick a point. Okay? And let's see, Charles, was it you? Somebody picked -42, right? So we picked a point way over here, and all we did was we just plugged it in. So if you plug in a -42, and I think I did get this right, if you plug in a -42, you have a 1 on the top, or in other words, the top is positive. The bottom is -42, so the bottom's negative. And what's a positive divided by a negative? It's a negative. So any point you pick over here past -1, the top's going to be positive, the bottom's going to be negative, so that entire branch is down here. Now, if you want to pick a decent point, right, like say you picked -2, and you wanted to label a point, let me see if I can do this right. 1, -2 plus 1. This would be 1 over -1. This point right here is -2, -1. If you wanted to label something so you made it perfectly clear you knew what you were doing, that might be a good point to label. It's really easy to find and graph. Okay, are there any questions? So we got all these things floating around. Horizontal asymptotes, vertical asymptotes, holes, proper, improper. We might have to do division to find an oblique or a slanted asymptote. Okay? We've got all these sketches. We want to find intercepts, both the x and the y-intercept. Okay, so we got all this stuff floating around. Okay, now, does this look as bad or as scary as it did yesterday? If you did 4.3, hopefully it doesn't. Okay? Now, I remember being in your shoes and seeing these and thinking, my gosh, how are we supposed to do that? Okay? But they're really not that bad. This is the part of your brain that gets worked out when you take 1050. Okay? If you think about how you've been taught math up until now, most of the time it's a concept or two at a time, and they're pretty easy. What happens in college algebra and trigonometry and calculus and stuff like that is it's not that you have to be a brilliant person in order to understand those. You just have to be able to keep that information in your head. Okay? Just organize all that stuff together. Okay? So that's what we're working on here. Very valuable skill. So let's take a look at this problem right here. The easiest thing to do on this is to look at it and figure out, is this proper or improper? Everybody ought to be able to get that right. Proper or improper? Okay, this is proper. If it's proper, you can immediately say something about the graph. Without even plugging in any points or graphing anything, you know something about the graph. What is it? Horizontal asymptote of y equals 0. Y equals 0 is a horizontal asymptote. Okay, so we got that part taken care of. Okay, what would we want to figure out next? Yeah, vertical asymptotes, holes, and stuff like that. Usually we do that by factoring. So I'm going to factor the bottom. The bottom is going to be x minus 3 and x plus 3. Okay. Are there any problems in the domain? Remember, this is a rational function. It's got division in it. Anytime you have division, you've got to be careful with the domain. Is there a number that we can't plug in here? Okay, so this one's 3, and this one is -3. Now, do either of those cancel? No. Okay, there's nothing to cancel with on the top, so that means that both of these are vertical asymptotes. Let's find some intercepts. I'm going to make a little xy table. I'm going to plug in a 0 for the x. I'm going to plug in a 0 for the x. Make sure I get this right. If I plug in a 0 for the x, the top is a 2. The bottom would be 0 minus 9, so that would be negative 9 on the bottom. So this is negative 2/9. Is that okay? Now, a year or two ago, or even in 1010, that would have been a whole problem right there, just finding the intercepts. Okay? Let's find the y-intercept, or sorry, the x-intercept. Let's plug in a 0 for the y. So we're going to take this and we're going to set it equal to 0. Now, I'm going to write this big ugly mess, but if you were paying attention to what I said yesterday, you really don't have to write all of that. What's the only part of a fraction that can make the whole thing equal 0? Just the numerator. So really, we could ignore this stuff down here. We don't even need that. What we're asking ourselves is, does the top ever equal 0? Does 2 ever equal 0? Nope. So what that means is, there are none. There are no x-intercepts, none whatsoever. Okay, now, that actually is a huge piece of information. It's actually really nice when there are no x-intercepts because that's going to help us graph it. We're going to need to use our head, but that'll actually help us graph it. So if you take a look at this piece of information, vertical asymptotes, this piece of information, horizontal asymptote, we know we've got at least one point on the graph. We've got the y-intercept, and we know there are no x-intercepts. That means this never, ever crosses the x-axis. It never touches it. It's never got a point on the x-axis. Everybody good there? Okay, let's come over here, and let's mark these pieces of information. So we've got a horizontal asymptote of y equals 0. So we'll draw a big dotted line. We'll write y equals 0 is the horizontal asymptote. So we'll label that. We've got a vertical asymptote at 3 and a vertical asymptote at negative 3. So we'll draw a big long vertical line at each one of those. X equals negative 3, x equals 3, and I'll just write VA by each of those so we can remember what they are. So I've taken care of the asymptotes. Now I need to put the y-intercept on there. The y-intercept is at 0, negative 2/9. So about right there. That is actually a point on the graph. Okay. Any questions so far? Now, the fact that there aren't any x-intercepts is going to help us graph this. And the fact that we've got a vertical asymptote here and a vertical asymptote here helps us know how many pieces we're looking for. How many pieces or how many branches will we have? 3. One over here, one over here, and one over here. Okay? So we're looking for 3. Now the easiest one to find is actually the one where we already have a point. Start with that right here. The graph's got to go through this point right here. Now remember, when we approach a vertical asymptote is a line that approximates the graph. So the graph's either got to go up and get really, really steep, or down and get really, really steep. Okay, it's got to increase without bound, we say sometimes, or decrease without bound. Can this one come over here and go up? Why not? No x-intercepts. So on this side, it's got to go down. And over on this side, can it go up? Nope. Now, if there were an x-intercept right here, that would be really helpful. We could just make it hit there and then go up. But we know it doesn't cross the x-axis, so it's got to look like that. That's what the branch on the inside looks like. Charles, can you help us find this one over here? Don't say negative 42. Negative 4. Okay, it might be a good idea, since we can actually label this one right here, this is 0, negative 2/9. It might be a good idea to pick one that's easy to plug in and that we could actually find on the graph. So this is the x is equal to negative 4. Let's plug that in. So if x is, whoops, if x is -4, let's figure out what the y is that goes along with it. The top's going to be a 2. The bottom's going to be a 16 minus 9, so that's going to be 2 over 7. Did I get that right? Okay, here's what I really care about. Everybody listen. I like the fact that you're going to be able to label a point, but this is what we care about. What we care about is that the top is positive and the bottom is positive. So a positive over a positive, any point you pick past here is going to have a positive on the top and a positive on the bottom. That means it's always going to be positive. So what does the graph look like? All up here or all down here? Okay, it runs along here, a little above the x-axis, and then it goes up like this. Now, if I label this point as -4, 2/7, even though it doesn't look like 2/7, that's not too bad. I mean, if you knew it was 2/7, maybe you'd want to make it a little bit less tall, a little shorter if you want. Okay, but that's fine. Okay, Kang, what point do you want to pick over here? +4. So if we plug in a +4, let's see what we get. I'd still have a 2 on the top. This would be 16 minus 9, so it's still going to be 2 over 7. The point is it's going to be a positive on the top and a positive on the bottom. So it's got to be all above. And I can label that point as 4, 2/7. Now, take a look at that graph. If this were on a test and you saw all of this work and this graph, vertical asymptotes labeled, horizontal asymptotes labeled, each branch has at least one point on it. You've made it clear that you know it extends forever in each one of those directions. Is that pretty convincing? Okay. This is what you can expect to see on the test. This is what you can expect to see in 1050. Okay. This is called analyzing a rational function. That's describing everything about it. Where are the vertical asymptotes? Where are the holes, horizontal asymptotes, or slanted asymptotes? What are some points, x and y intercepts, all that sort of stuff? And what do each one of those branches look like? Okay, are there any questions? When you plug in a 4, you square that. Okay. You could plug it in here also. It would produce the same answer. Good? Okay. All right. So, a couple of thought questions here. Can a graph touch a vertical asymptote? Answer there is no, absolutely not. Why not? Because it's the asymptote. Why is it an asymptote? Why is that a vertical asymptote? Yeah.
Because it can never equal, 0 can never equal number above 0.
Okay. The denominator can't be 0. Or here's what we're really after. That point is not in the domain. Like 3 is not in the domain. Okay? Point is not in the domain. That's why it's a vertical asymptote. Okay? It's not even in the domain of the simplified function. Can a graph touch a horizontal asymptote? Who said yes? Okay. Josh is right. The answer there is yes. Okay? But we're going to say this. Usually only in the middle. Okay? Good grief, that looks like Michelle. It would help if I used a smaller one. Usually only in the middle. Okay? So it's going to approach this horizontal line out on the ends, but in the middle here it can kind of wiggle around. Let me show you an example of one where we cross a vertical asymptote. Horizontal asymptote. There's a horizontal asymptote right here. It does actually cross this. This is why the range is from -infinity to infinity. It crosses it right there. There's not a problem crossing a horizontal asymptote. There is a problem crossing a vertical asymptote. Okay? These graphs would never do something like this. Okay? There'd be a point there. Okay? All right, any questions? Is this easy? Or not too bad at least? Okay, all right, let's take a look at the next one then. We're going to run through the same steps. The very first thing you can do just when you look at it, so Max, if you were to take a look at that one, we can ask ourselves, is it proper or improper? What is that one? That's improper, okay? So this is improper. Good or bad?
Good.
Good. What does that mean? Y equals, leading coefficient of the top is 2, leading coefficient on the bottom is 1. So that means we've got y equals 2 is a, what do we call this again? Horizontal asymptote. So I've got the horizontal asymptote.